activation function, then cost function. Cost function is also known as error function or loss function. Okay. Then we have gradient descent optimizer, and last one is back propagation. So these are the topics that I will be covering in this slide. Okay. Now, the first one is the neurons or perceptron. Now see, basically, what is the idea behind artificial neural network? Rest of you, please mute yourself. There is some noise coming from the background. Ma'am, kindly mute yourself, ma'am. Noise is coming. Ma'am, some noise is coming. Kindly mute all the participants. Yeah, okay, thank you. Okay, so the basic idea behind the artificial neural network is basically the concept of the human brain. Basically, in this one, we are going to create a human-like brain. Just like we have a brain, we are just going to create a replica of the human brain. As if our brain works, we are going to create a system that is based on our working of the brain. So you all must be knowing that in our brain, there are neurons present. Now, can anybody tell me what is the use of neuron that is present in our brain? What's the use of the neuron? Anybody can tell me on the chat? What is the use of neuron? You must have studied in your junior classes. I think no one remembers that. Okay. So basically, neuron is what? It is basically to carry the information from various organs to the brain. Ha, correct. Basically, it carries the information, carry the data from different organs to our brain or to the next neuron also. The main role of neuron is to carry the information, to hold the information, to carry the information from one place to the other place, basically, okay, in our brain. And that's a very important part, actually, of our brain. Without neuron, nothing can be done. Okay, so basically, the same thing, the artificial neuron, we are going to create an artificial neuron that will do the same thing that it performs in the brain. Okay, so basically, neurons are what? A very important part of brain through which the signals are transmitted. Artificial neural network is based on natural neural biological system. I mean here, neural biological system that we have in our brain. Okay. Artificial neural network is a software-based approach to replicate the biological neuron. Just whatever I just told, the same thing. That we are replacing replicating the biological neurons. Okay. Now let's discuss something about biological neuron. You also must be knowing about this, but let me tell you in short about biological neuron. Now this is how your biological neuron looks like, right? We have dendrites, we have nucleus, we have cell body, axon, terminal. These are the major terms related to the biological neuron. So let's discuss one by one. Now the first one is the dendrite. Anybody know what is the use of dendrite?
Yeah. The collection of information.
The collection of information. Yes, basically from the dendrite only, it accepts the information. all the inputs are accepted by the dendrite or collected by the dendrites only. That means from here the inputs will be received. And it also connect the other neuron. Yeah, correct, Lengu, correct. It also connect the other neuron. So that's the role of dendrite. After collecting the information is sent to the nucleus. It is sent to the nucleus, and the role of nucleus is to decide the output according to the input. That what will be the output according to the input received. And then that output is transferred, or we can say moved from through the axon to the axon terminal. So through here, through nucleus, it transfers from through axon to the axon terminals. The input will be transferred from here to here. After the transfer is done, so from here, it is again sent to the other neuron. So here the other neurons will be connected and it is transferred to the other neuron. So like this, the information goes on transfer and the information move from one place to another place. So this is about the biological neuron. Okay. Now let's discuss about the artificial neuron. The concept will be same. This is the block diagram for the artificial neuron. Now let me explain you in the whiteboard this part. That will be more better for you to explain. I'll give a simple example to explain this. Just hold on. I close my door. Some noise is coming. Okay, see. Now, how does this artificial neuron work? So for explaining you this, I'll give you a simple example. I'll take an example of a problem statement. Suppose this is the image. Okay. This is the image on which some number is, some handwritten digit is there. Okay. And this practical we are going to do today also. Okay. So some hand digit number is written there. And I want to predict that what is the number written on this image. So obviously we can see that the number is 7, right? You can see that the number is 7. But this same thing I want to perform with the neural network from the artificial neural network. Okay. So basically what we will do in this, see basically we have two types in artificial neural network. The first one is the simple neural network and second one is the multi-layer neural network. Multi-layer neural network. So in the simple neural network, there will be only two layers. The first one will be the input layer and second one will be the output layer. Input layer will contain input, output will contain output. That's all. But in the multi-layer, in between input and output layer, there will be some more layer. It can be 1, it can be 2, it can be 3, depending on the problem statement. And these layers are called hidden layers. So in case of simple problem statement, you can go for simple neural network. But if you are not getting good accuracy with the simple neural network, you can go for multi-layer neural network. So right now, I'm just giving an example of multi-layer because this problem statement can be solved with multi-layer neural network. So as I already told you that there should be at least 3 layers: input, then hidden, then output. So let us consider that we have one input layer. Let us consider that this is my input layer. So on this input layer, I have simply passed my image. Now we apply some kind of processing to the image, some kind of image processing. And after applying that image processing, we divide the image into some array or something. And after dividing that, we pass into this layer. And this one is called neuron. This is your neuron. So any layer can have any number of neuron. That depends on the input will depend on the input layer. The number of neurons in the input layer will depend on the input data. Okay. And the other hidden layer will depend on you what you want to take. Okay. So I'll explain this in practical. But right now, just consider that we have only two neurons. Just consider that we have only two neurons. And I'm giving the name of the neuron as N1 and N2. N1 and N2. That's my name of the neuron. Okay. Now, input layer will depend on the input. Now data. The next layer is the hidden layer. The other hidden layer will depend. Please mute. So I'll explain this in practical. But right now, just consider that we have one mute. Consider that we have only two neurons. Please mute yourself. Neuron as okay, so now this is my hidden layer. Just consider that this is your hidden layer. On hidden layer, suppose I have taken 3 neurons. Right now, just consider the number of neurons. I'll tell you how to decide the number of neurons in the practical side. Right now, just consider that I have taken here 3 neurons. Okay. Now the output layer. On the output layer, it depends on you how you want to take. Let's suppose I want, on the output side, I want just the number, that what is the number of present there. In that case, I will take only 1 neuron. But if I want the probability of all the number, that there is 90% probability that it is 7, 2% probability that it is 6, 5% probability that it is 2, like this. So if you want the probability of all the digits, in that case, you have to take 10 neurons in the output layer. So right now, let us consider that I have taken 1 neuron, and that's my output layer. That's my output layer. Now all the neurons are connected to the next layer like this. Every neurons will be connected like this. Here it will be connected. So here it will be connected, and here it will be connected. Same thing here, then this, and then this. Now, when the first neuron makes the connection with the second neuron, they are assigned some weights. They have some weightage to the connection. Like suppose this is you, suppose, okay, and this is your friend A, friend B, and friend C. So basically, how you are connected to friend A? If you are closely connected to friend A, that means the weight of friend A is more. Okay. The weight of friend A is more. So that's the weight part. That's the weight part. That if the interface, like if this N1 will depend more on A, I will assign more weight to A. That's the weightage. Okay. So I'll tell you about the weight part also in the practical. Right now, just consider that we assign a random weight value. Random weight. Okay. So let's suppose the weight of this one is W1. The weight of this one is W2, and this one is W3 for the first neuron. Now, for the second neuron, W4, W5, and W6. Is there any rule for connection? No, there is no rule. Every neuron is connected to each and every neuron. That's a rule only. That if this is a neuron, it will be connected to all the neurons on the next layer. It should be connected to all the neurons. Okay. Now, same thing here also. Here, suppose WA, WB, and WC. Now this is the connection that the neural network will make. The neural network will be like this. Now, what will be the output of this layer? This neurons now. Now, how this neuron will work? So the mathematical model for a neuron is y is equal to summation of I is equal to 1 to n xi into wi and plus bias. Here bias is outside this. So that's the mathematical model of this neuron. Y is simply the output of this. The output of one neuron. Y is equal to the output of neuron. That means the output that I will receive here. Okay. Now, X is your inputs and W is your weights. Now I'll discuss about bias after some time. What is this bias? Now see, what will be the output of this one first? The output of A first, A. So Y is equal to, now summation of Xi into Wi. So here, what is Xi? Xi is this N1, okay? So let us consider that this will be your N1. So N1 multiplied by tell me what is the weight of N1 on A? What is the weight of N1 on A? Yeah, it's W1. Correct. It's W1. The weight of N1 on A is W1. Now plus. Now the other input that is coming on A is this line, right? That is N2. So N2 into, now what is the weight of N2 on A? W2, correct. So that's W2. And plus bias. So this is your output. Okay. So now let's suppose after solving this, I get the value at 6. Let's suppose after solving this, I get the value at 6. This is just I am supposing, okay? Just I am assuming that the values got here is 6. Okay. Now what is this bias? Bias is any small value. It's any small value, any small constant value that is that helps to keep the neuron active. To keep the neuron active. In which case, suppose your N1 and N2 is 0. There is no input. So tell me, when there is no input, in that case, what will be the value of this summation? 0, right? If there is no input, the value of this summation will be 0. So in that case, if I will not add the bias, the output for this neuron will be 0. That means this neuron will become inactive. And neuron is inactive means if your some part of the brain, a neuron, is inactive, that simply means your brain is not performing well. So when the brain works better, that means all the neurons are working better. Sometimes we say na dimag ki batti jalao. We say like this, dimag ki batti jalao. That batti jalao means that keep your neuron active. That simply means. that we have to keep the neuron active every time so that our brain works in a better way. So if we add some bias value, suppose 0.1 or 0.01, any small value you can take. So in that case, there will be some value here. It can be any some value. And in that case, that is called bias. Any small value you can take and it will not make the neuron inactive. Am I clear, all of you? So this is the rule use of bias. So now here I got the output as 6. Let us no, not this. After this also there is one more thing. Now this will not be your final output. This will not be your final output. The final output will be after getting this output, we pass this output to the activation function. Now here activation function is just like a nucleus that is in our brain. It is just like a nucleus. The role of activation function to take the input, the output near to your desired output. It makes closer to the desired output. And it's nothing, it's simply a mathematical function. It's simply a mathematical function. It can be sigmoid, exponential, ReLU, tangent, softmax. Lots of functions are there. I will tell you what are the standard function, activation function that we use in the neural network. After some time, I will tell you. Okay. So right now, let us assume that I am using an activation function fx is equal to 10 minus x. No rule why I've taken 10 minus x. I'm just assuming that I am using this. And the selection of activation function depends on the output. So I'll tell you when I will teach you the activation function part. Right now, just assume that this is my activation function. So what will be the final output? That will be 4. That will be 4. So that means this 4 will be coming here. Now tell me, what will be the output for B? N1 into what? W2, right? Plus N2 into W5 plus bias, right? And let's suppose I got here 3. After solving this, I got here 3. And after applying the activation function, I got here 7. Okay, I got here 7. So let's suppose the output for this one is 7. Similarly, the output for this one is 6. I just assume that after solving, we got this output. Okay, so my hidden layer is completed. No, yeah, the activation function is same for one layer. You can take each same activation function for every layer, but depends on the problem statement, depends on the output that you want. Generally, in the hidden layer, we take the ReLU function. I'll tell you what the ReLU function in the coming after some time. Okay. So if you are using activation function 10 minus x, so 10 minus x will be applied to all the neurons in the layer. It will not like that for one neuron there will be another, for second neuron there will be another. No. Same activation function will be same for every layer. Yes. Okay. Now here, the same thing. What will be the output? The final output. The final output 4 into WA plus 7 into WB plus 6 into WC plus bias. And let's suppose after solving and after applying the activation function, I got the value as 6. So here I got the value as 6. So this means that in this layer, the model was confused with 3 values. That it can be 4, it can be 7, it can be 6. But finally, after thinking some time, after doing some kind of calculation, he said that the final output is 6. So tell me, is it the correct prediction? No. So how we will know that whether it is correct or not? You can calculate the error. That calculation of error is called as cost function. So what will be the error here? Actual minus predicted. And that is 1. So this error should be very low for a good model. It should be near about 0. So if there is a layer, so we can say that there is a mistake. So in that case, when there is an error, what we will do, now coming to the next part. No, bias, we'll keep the bias same. So that's my neural network, right? Now if I get here wrong output, it will go back to the previous layer and it will say to the previous layer, not actually say, I'm just explaining you to that we got a wrong output, make it correct. So this layer will also go back to this layer. It will also say that we got the wrong output, please make it correct. So make it correct means it will change all the values of weight. All the values of weight will be changed, will be adjusted. Will be adjusted now. How many weights we have taken? 9 weights, right? So all the 9 weights will be changed. Okay? Please mute. All the 9 weights will be changed. And after changing the weights, the same process will be applied again. The same process will be applied again. Okay. So going back to the layer and changing the weight is known as back propagation. And calculating your new weight so that we can get a correct output is known as gradient descent optimizer. Gradient descent optimizer. Okay. So the role of gradient descent optimizer is to change the value of weight, or we can say that calculate the new value of weight so that we can have the least error. Okay. And the role of back propagation is to go back to the layer and apply the new weight. Let's suppose I got the previous weight was 5 and my new weight is 7. It will go back to the layer and it will change this 5 to 7. That is back propagation. Am I clear? So like this process goes on continue till we get the least error until we get the desired output. So this is the overall working of your artificial neural network, multi-layer perceptron network. Am I clear? The formula of gradient descent I explained. Right now, just understand that gradient descent change the value of weight to get the desired output, to get the least error. That's a gradient descent. I explained in the PPT. Okay. Okay. Now let's come back to the PPT now. So this is the complete diagram of a single neuron. I just explained the same thing. All the inputs are coming and all the inputs are having some weights. Then all the weights and inputs are multiplied and then taken the sum. Okay, after that we add the bias and then this is applied to the transfer function. That is actually activation function. And after applying the activation function, we finally get the output. Okay, so that's a neuron. Now this thing already I explained. That's a mathematical model. This multiple perceptron network. Main role is to calculate and decide the output. Now, what are the types of activation function that we generally use in our neural network? Step function, sigmoid, hyperbolic tangent, rectified linear unit, that is ReLU. And one more is there, softmax. I'll explain that softmax also. Now let's discuss this one by one. Let me tell you something in short about this one by one. First one is the step function. So this is your step function. That the graph, you can say the line of this step function is this, and fx is equal to 0 if x is less than 0, and fx equal to 1 if x is greater than 0. So there will be only two values, either 0 or 1. So if our output is either 0 and 1, then we can use step function for that purpose. Okay. If you want your output in the form of 0 and 1, then you can go for step function. How we know the correct value so that we calculate? By calculating the error, you will know the correct value. If the error is near about 0, that means the value is correct. Okay.
Sir?
Yeah.
Sir, my question is that, sir, how to know the correct value, sir, so that we will get the error? Means in a model
we already should be having the correct value. This is a type of supervised learning. Here the output is already known. See,
yes, sir.
I'll tell you. This is my x, this is my y. Okay. So we will pass this value to my neural network. Okay. And for this value, the neural network will give participant, please, all of you mute yourself. See, some noise is coming and that is disturbing me also. So that's ma'am, please mute all the participants. So that disturbs me. That is just my concentration. Who is that? From where this noise is coming?
Lokesh Kumar Bharma, sir.
Let me call ma'am and let me tell. Just a minute. That's okay. Yeah, so I was saying that we'll pass this input to the neuron, and for all this input, we will get some output like 2.4 or something like that. Now we already know this. This thing we should already know. Then from here we'll calculate the error. Got it? When I'll explain you the practical part, then you will clear about all these things. Then how we'll know that how much error. Wait for some time. Your doubt will be cleared in the practical. Okay? Because the output will be known. Now, sigmoid function. Just hold on, but let me call man and tell me. Just give me a minute. Many participants are on. Okay. Now, sigmoid function. It is like a continuous function where the output will be between 0 to 1. The output will be between 0 to 1. So here we take the threshold value of 0.5. Take the threshold value of 0.5. Just hold on. Hello? Hello? Okay. Now that's okay. Yeah, so this is 0.5. We consider this as a threshold value 0.5. If I am getting the output greater than 0.5, we consider that output as 1. And if we get the output less than 0.5, we consider that value as 0. So this is more precise than the step function. So wherever you want your output either 0 or 1, I will suggest that you go for the sigmoid function. So if my output is either 0 or 1, or we can say the output is in the form of binary classification, like where I have to predict yes or no, true or false, cat and dog, like this. In that case, we can go for sigmoid function. And the equation of sigmoid function is 1 divided by 1 plus e to the power minus x. That's the equation of sigmoid function. Okay. Now tangent function, here the output is between -1 to 1. Okay, -1 to 1. So if you want your output in between -1 to 1, you can go for the hyperbolic tangent function. ReLU. This ReLU function basically we prefer to use in the hidden layer because the accuracy after taking the ReLU function is good. And what does ReLU function do? This is the equation for the ReLU function, max of 0, x. That means out of 0 and x, it will give you the maximum number. If 0 is greater than x, the output will be 0. And if x is greater than 0, the output will be x. So that means we can say that the range of this one is 0 to infinity. So wherever you want any number, like it can be any positive number. If you want any positive number, then you can go for ReLU function. Okay. Yeah, I will share this PPT. I'll share this. Okay. Now, one more function is there that is not in the PPT, that is softmax. Softmax function is used in the case of multi-classification problem. Like we have more than 2 class. Like you can take an example of that handwritten digit. If I want to get the probability of all the digits, That means there will be 10 class, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. I will get the probability of each digit. That means there will be 10 outputs. So in that case, you can go for softmax. Softmax will give you the probability of all the class. Okay. Cost function already explained that this calculates the error difference between the actual and predicted values. And this is the overall formula for the cost function, summation of y minus a ka whole square divided by n. And this is actually what? This is actually mean square error. This is mean square error. Okay. So basically for a simple neural network, you can apply this because it works better in a simple neural network. But in case of a complex problem statement or a multi-layer neural network, it is not recommended to use this because it slows down the learning of the neural network. It makes the neural network slow. So in that case, we prefer to use cross entropy to calculate the error. And the formula for the cross entropy is this: -1 divided by n, summation of I equal to 0 to n, y into log of a plus 1 minus y into log of 1 minus a. So that's the cross entropy. Okay. Now, gradient descent, already explained that it is an optimization algorithm for finding the minimum value of a function to reduce the cost. So it finds out the final weight, the value of the final weight at which the cost is less. Cost means the error is minimum. And the formula for the gradient descent and back propagation, I'll tell you how does it calculate actually. See, the formula is actually W new, that means new weight is equal to W old plus alpha into dy by dx, where y is your activation function and x will be your predicted output. X will be your predicted output. So we take the derivative of the activation function and we pass the predicted output in that derivative function. And then we multiply it with alpha. Alpha is your learning rate. Learning rate. Basically, this is your alpha. At what rate we are changing the value of weight. That's the alpha. So in place of alpha, you can give any small value and you can pass the error value also. In place of alpha, any small value is allowed. It's not like that there is some fixed value or something. You can pass any small value. So it's better that you can pass error in place of calculating the other value and pass it. Okay. So this is the formula. So this part actually, this part is known as gradient descent. Okay. And this complete step is known as back propagation. Back propagation. Am I clear now? What is the role of gradient descent now? Okay. So that's all. That's all for this neural network. So now I'll tell you about we'll move on to the practical and we'll do a short practical right now related to the simple neural network, and then we will move to the multi-neural network. So in the simple neural network, I'm not going to use the library. I'm just going to apply from scratch. That means whatever the formulas I just explained right now, I'm going to apply all the formulas that I explained in this artificial neural network so that you can have the clear concept about neural network. Okay, that how actually these formulas are working, how it is calculating, how it is giving result. These all things we are going to do now. And after this practical, your complete your all the doubts will be completely cleared. Okay, so now let's start it. Let's start the practical. So open the Google Colab. I'm just having some water. Just give me a minute. Okay. So I'll take a new notebook file. Okay. So now, first of all, let me explain you what problem statement we are going to take. I'll take a simple problem statement as we are going to do a simple neural network. We are taking three inputs. We are taking three inputs and one output. Okay. So let us consider four sample 0, 1, 0, 1, 1, 0, 1, 0, 1, and 0, 0, 1. I've just considered any random four sample and random four output. Okay. So basically this output I have just taken the same like X1. So suppose this is my output, this is my data that I want to use in our neural network. So I will be passing these three as an input in my neural network. And I want this output from the neural network. So let us see that output that we are receiving is same or different. Okay. So now let us do that. So give the file name here. Simple neural network from scratch. Okay. Now for creating this data, this one, we are going to use the NumPy library. In the form of array, we will create the data. We can take X. Zero, 1, 0, 1, 1, 0. Okay. 1, 0, 1, 1, 0, 1, and 0, 0, 1. 0, 0, 1. That's my X. Now the output is 0, 1, 1, 0, 0, 1, 1, 0. So I've simply created here X and Y. X is my input and Y is my output. So if I print X, that's my X and that's my Y. So we have created the input and output now. Okay. Please complete this, all of you. Completed. Okay, fine. Now we have the input and output. Now we will move step by step. So first of all, what we have done here, we have assigned the weights to all the inputs, right? Now let us assign the weights. Now tell me, how many weights we require here? How many weights will be required here? Anybody? How many weights will require here? Tell me. Four. Okay, I'll send the link. How many inputs are there? Yeah. How many inputs are there? We have only three inputs now. X1, X2, X3. X1, X2, X3. We have only three inputs. We have four samples. Don't confuse with sample. These are the samples, not inputs. So we have only three input. So that means there will be three weights. So initially, we assign any random value of weight. And afterwards, we change the gradient descent optimizer will change it to the final one. Because initially, we don't know what weight we have to pass. So initially, we can pass the random weight. Okay. So let's create a random weight. So weights is equal to np dot random. Okay. And here I will pass 3, 1. That means I am creating a 3 cross 1 matrix. 3y because why 3? Because we have three inputs. And this is random weight. Everyone will get a different value. Okay. We can do one more thing in this. What we can do is, see, every time I'm running this, so this weight is, you can see it's changing. Every time it is changing. So we can fix this weight. We can fix that it should not change every time. So for fixing this, I can write here np.random.seed. And you can pass any value here. Let's suppose I pass here 1. Now the weight will be same for, now it is very small number. So let's take another value here, 10. Yeah, now that's okay. So here 1 and 10 do not have any relation with the output. Here 1 and 10 is just like an address. That for 2 I will get another sample. For 3 I will get another sample. So this is like a address, you can say. Okay. So you can take any value here. So let's suppose I will take here 10. So now I have got 3 weights. This is the weight of x1. This will be the weight of x2. And this will be the weight of x3. Do it. Do it, all of you. Okay. Now tell me, after assigning the weights, what we have done. Now we want the output. So for getting the output, what we have to do? Tell me. Multiplication, apply the form multiplication and addition. Yes, we have to multiply the input to the weights and then we have to add this. So I hope you all know the dot multiplication of a matrix. I hope you all know this. So if I do the dot multiplication of this one to this one, so can we say that we are doing this operation? This operation? Tell me, all of you. This one. This one. Can we say that? If I'm doing a dot multiplication of the x and weights, please explain. Ahim, what Ahim? No, I'm saying that if I do the dot multiplication of this and weight, first of all, tell me, do you all know about dot multiplication of matrix? I hope you all know this. You must have studied. if I do the dot multiplication like this, zero point 0.02, 0.6. So in the dot multiplication, what does it do actually? 0 into 0.77 plus 1 into 0.02 plus 0 into 0.63. So this will be the output for the first one. Then here 1 into 0.77 plus 0 into 0.02 plus 1 into 0.63. Like this, it will goes for all four. Tell me, this is only dot multiplication, na? Yeah. So can we not say that this is doing actually x1 w1 plus x2 w2? This is x1 0, and the weight of x1 is this. This is x2 1. The weight of x2 is this, right? So let's do this. So sum is equal to np dot multiplication of x and weights. Now let's see. That's my dot multiplication of weights. And we have to add a bias also, right? So let's take the bias as 0.02. That's my bias. That's all. I hope this thing is clear, everyone. Tell me. So here I've done the weighted sum of input and weights, and then we have added the bias. Now, so that means what I got here? I got actually this thing. This one I got. Now what we have to do, we have to apply the activation function to get my desired output. So tell me which activation function will be better for our problem statement right now. My input layer is completed. Now we have to do for the output layer. So tell me. And this is your input layer only. Please import the NumPy library, man. Import NumPy. Step function. Can I say that sigmoid function will be better here? Step function will directly give me 0 and 1. I will not be able to find out what actually the error, how much error is there, right? Because it will be either 0 or 1. It will simply round off. So I told the sigmoid will be more precise. So let us apply the sigmoid function. Okay. So let us make a separate function for sigmoid, and then we will apply. So DEF, let's suppose I'm giving the name as activation. Of X, return. Now here I have to pass the equation of the sigmoid. So what is the equation of sigmoid? Anyone? I explained in the PPT. One divided by 1 plus e to the power minus x, right? 1 divided by 1 plus e to the power minus x. So 1 divided by 1 plus e. Now how to write e? Np dot exponent. This is your e minus x. That's your sigmoid. Okay. Done. So now let's get the predicted output is equal to activation of in place of x. What I will pass here? Tell me. What will be the input here for activation? Weights. No, 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 no. What we pass in value of x here? Sum. Yes. It will be sum. So this is my output. I told you that in sigmoid, we take the threshold value as 0.5. So keeping in mind the threshold value, tell me what is the final output we got here. Ma'am, you have not executed this code. You missed this part. Kindly open this link and get all the codes. Sri Ganesh, after writing every step, I give the time to write the code. Right now, I am explaining something. So after explaining, I always give the right time to write the code. But while I am explaining, don't write that time. Otherwise, you will be obviously feeling that you are lagged. So right now I'm explaining, please wait. I will give the time to write. Okay? Because till here already I've given the time to write till here. Now, so now tell me what is the final output we got here? Can anybody tell me? After keeping in mind the threshold value, what is the final output? Why? No, 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 no. Why is the actual output? I'm talking about the final, the predicted output. What I told that the value greater than 0.5 will be considered as 1 and less than 0.5 will be considered as 0. So in the form of 0 and 1, what will be the output here? 1, 1, 1, 1. Yes. But what we were expecting? We were expecting 0, 1, 1, 0. That means there is a mistake. So we will reduce that mistake now. So first of all, complete till here. And then I will apply the gradient descent and back propagation to reduce the error. Complete till here, all of you. All of you have done? Okay, fine. Now we will reduce this error, and for this we will apply gradient descent and back propagation. Now, I've already told you the formula for gradient descent. So let's create a function, and before creating a function, let's calculate that how much error we have. So let me write the code in a single line. So error is equal to, now what will be the formula for error? Actual output. So actual output is how much? Y minus Y pred. That's my error. So we have to reduce this thing. We have to reduce this error near about 0. We have to take it near about 0. So now let's create a gradient function. I'm giving the name as gradient. So your A is your alpha and X is your input. X will be your input. Now, so it will be alpha multiplied by derivative of the sigmoid, derivative of the activation. So activation is sigmoid. So anybody know what is the derivative function of a sigmoid function? If you take the derivative of sigmoid, what is the output? Anybody? What's the derivative of sigmoid? Okay, I'll tell you. It's x multiplied by 1 minus x. That's the derivative of sigmoid. X multiplied by 1 minus x. So that's the gradient. Now let's apply this gradient descent. Now tell me, first of all, let us calculate the change in weight, that how much change the weight should be done. Change in weight is equal to gradient of, now tell me, in place of A, what I will pass here? Learning rate. What will learning rate? I told you, in place of learning rate, what do we pass? Error. And in the X, we will pass Y pred. So this is the change that we have to do in the weight. So this is actually called gradient descent. Okay. And now we will apply the back propagation. That means we will change the weight. So weights is equal to, I'm changing the previous weight. Weights is equal to weights plus, now again you have to do the dot multiplication and then you have to add. Okay. So can without bracket also. NP dot product of x comma change in weights. Now see, if I execute this, I'll get the error. Why? Because the shape of x is 4 cross 3 and shape of this one is 4 cross 1. So tell me, can we multiply these two matrices? Is dot multiplication of these two matrices possible? Can 4 cross 3 can be multiplied with 4 cross 1? No. Then what we have to do? Now, if I take the transpose of this, that means 3 cross 4 and 4 cross 1, then it can be possible or not? Yes. So I'll write here T. That's a transpose. And now we got the weights. Okay. Now the gradient descent and back propagation is applied. Don't do it right now. I will explain this, then you do it. Okay. Let me complete this first. Now see, if I print the error right now, if I print the error, now just look the previous error and just look the current error. Do you find any change right now? Is it reduced or is it increased? Little bit, yes. So if I execute again, now see, again reduced, right? If I execute again reduced. So to take it near about 0, what can we do? Tell me. What should we do to take it near about 0? Can we do this in a loop? So for I in range, let's do it for 1000 times. There is no rule for this. More you will train, more the error will be reduced. So it's called training, okay? Doing the same thing again and again. And let's do all the things in a loop. I'm printing the error outside the loop, okay? Now, so after executing this code 1000 times, so my error is this. So tell me now, is it not near about 0? And now if I print my actual output, y pred, the prediction output. Now tell me, what is the output we got here? If you round off this, if you take the threshold value, what we got here? Zero. This will be equivalent to what? 0, 1, 1, 0. So tell me, did we get our desired output? And if you see the final weight, now tell me whose weight is greater here? Whose weight is greater? X1, X2 or X3? X1. So why X1 is greater? Because our data was mostly depending on X1 only. See, can you see all of you? 0, 0, 1, 1, 1, 1, 0, 0. So model automatically adjusts the value of weight according to the data. This is how your neural network works. I hope now your all doubts are cleared. Those over who are having doubt, now I hope you understood this one. Last point. Which last point? This one you are saying. Which last point you are saying? Because you can see the data. You can see the data here. X1 is 0. The output is also 0. X1 is 1. The output is 1. X1 is 1. Output is 1. X1 is 0. Output is 0. So can we not say that the output is depending on X1? Tell me. That's why. Okay. So now you can complete this, all of you. Complete this. Achha, I've given the spelling mistake here. Correct this. There is a problem of an indent. Please check. There is a space here, tab space. Completed, all of you? Ma'am, please give the tab space here. I'm copying my code on the chat. Please copy and paste. There is a tab space here. You have to give the space by tab button at each line. If you've already given, then there should not be the problem. Just check there is some problem. Semicolon. Acha, हाँ, you have given semicolon also. Yes, you have given semicolon also. Here you have given semicolon. Not appropriate. Have you executed the loop? I don't think you have executed the loop part. Please check this. I don't think you have executed the loop part. Please execute all the code again. Execute all the code again. Okay, all of you have done. Okay, this was all about the simple neural network. Now, after this, we are going to use the library and we are going to use the multiple neural network for the image data set, and that will be the handwritten digit, the example that I discussed. Okay, so we'll take a break now, and after the break, we will continue that second practical. Okay, all of you. Let's take a break of 15 minutes. So at 1:15, we will continue. Am I clear? Page link. Okay, I'll give you the page link. That's the page link. Okay. Yeah. I'll just come at 1:15.